All right, get going here. This time we're going to be testing, let's see, ABS and ASA. And got a little bit of different setup here. So trying this out. Okay, this is ASA with carbon fiber by 3DX Tech. We're going to be using 3DX Tech, Soraya Tech, and atomic filaments this time. ABS and ASA are pretty similar. They print really, really nice. And yeah, this stuff I've used for a couple of different projects. So, in case you're new, we've got five test parts that are printed in the horizontal plane, and then five test parts that are printed vertically. Okay, so we're going to get set up for the tests that are running in the XY. ASA, carbon fiber, 3DX Tech, XY. All right, here we go. Okay, so we're seeing about 1200 newtons. And around 1200 again. All right, right about 50 megapascals, pretty consistent results. Looking good. Okay, so now we're going to be running the z-axis test. Yeah. Oh, shoot. I forgot. I needed to sand these a bit. So, you'll see me fighting with these z-axis parts this entire stream. Only about 400 newtons on these guys. Not much to write home about. Oh, not even 400 that time. Like I'm barely applying any force. So, 300 something there. All right, last of the ASA with carbon fiber. Okay, 300 something. What do we got? Yeah, boy, 6.2 megapascals. That's possibly the worst I've seen. Okay, ABS with glass fiber. Let's see if I can get you a decent view here. So this stuff has a bit of a rough texture. Also made by 3DX Tech. Let's get the test set up. ABS, glass fiber, XY plane. Get this going. Make sure this stream is actually running. Okay, looks that way. Hope it is. First time with YouTube live streaming, so it's gonna be a little rocky. It looked like about 1200 newtons. Same ballpark as an ASA with carbon fiber, at least on the XY. One more. Okay, about 1200 again. Okay, yeah, pretty close, pretty close. Okay, z-axis test. Let's get going. Better. Is it about 700 newtons? Definitely better. All these are gonna get stuck. Okay, trial three. Number four. So not great consistency. I think I'm gonna see a fair spread in the z-axis forces. Real easy on the handle. Doesn't take much. Okay, where are we at? So 775 on the top, 462 on the bottom. So we're better than the ASA, but boy, not by a whole lot, huh? And it looks like I just lost one of my cameras. Hello. Flaky cable. Great. Sorry, one moment. Let me see what I can get. See if I can fix this. All right. Well, I guess we're down camera. And we're just about down a tensile tester too. Okay, how about we do an ASA with glass fiber by Tech. Trying to get you a view here. This is also got a rough surface. The glass fiber filaments usually print with a bit of a rough texture. And let's see how this performs. Okay, XY. This is ASA with glass fiber. ASA with glass fiber. Yes. And it is Tech. Off to the races. I think so that's about 1400. And I think we got a winner for this round. Another 1400 or so. Move this camera out of the way. It's ain't working anyway. All right, got another 1400 there. Let's see what we got. Yeah, a little over almost 57 megapascal. That's pretty good. It's definitely a winner for today. Okay, let's try the Z-axis. 900 and change. Yep. Saw that one go a little above 8. Noticing a fair number of these parts not break at the waist. Let me see if I can give you a view of this. So the thinnest part is right at the waist, but they're breaking up towards where they're in the jaw. And so what that's telling me is they might be getting a twist to them. So I'm gonna have to see if there's something I can do better on the test fixture to eliminate any twisting. It's in line. That one broke a little closer to the waist. Maybe design a rail that both of these slide on. Still use the jack for the actual force. Yeah, I gotta think about that. I saw 900 newtons on there. Good. Making a mess as usual. Ooh, very low. And it didn't quite break the waist again. Yeah, I might have to do a little more work there. Okay, let's look at the data. 15 megapascals. We had two runs that were substantially shorter than the others, down 500s. Okay, well, here's what it is. Okay, in terms of discrete quality, this ABS carbon fiber from Atomic Filament is really, really nice. ABS generally it prints beautifully. It's used in injection molding all the time because it just flows into the tool well. ABS is what Legos are made of. Okay, so we've got atomic filament, ABS with carbon fiber. Oops, no, I forgot to set the axis. Okay, XY axis, atomic filament, ABS, yeah. Off to the races. North of 1,000 there. Uh, 1,100. So seem to be coming in around 1100 newtons. All right, how are we looking? Okay, right at 1100 newtons, 44 megapascal. Okay, off to the Z. We have a number of these. They're breaking up in the jaw. Ain't good. I'm not sure if that's due to inconsistent print or inconsistent loading. Barely had to apply any force to break these, at least the Z-axis one. Okay, so 12 megapascals, definitely not bad for this run, but I've seen better on the Z-axis. So all this data will be uh, up on my GitHub page. I will pin a comment with the video that has the link to has linked to everything. So thanks so much.